Uh, Welcome. I'd like to thank you for coming to our webinar that is sponsored by Carnegie Mellon University Scott Institute for Innovation and Catalyst Connection. This month's seminar is on virtual home energy audits via smart meter analytics from a company called EEme. Please type in your questions you might have now so we can answer them at the end of this presentation. This event is being recorded and will be posted on YouTube and the Scott Institute webpage. The Scott Institute for Innovation at Carnegie Mellon University is a new institute. It focuses on energy activities across the campus. Its key focus is on how the nation and the world can use and deliver the energy we already have far more efficiently, to expand the mix of energy sources in a way that's clean, reliable, affordable, and sustainable, and creating innovations in energy technologies, regulations, and policies. And this is the last bullet, which is the focus of our presentation today. Catalyst Connection is an economic development organization dedicated to helping small manufacturers in southwestern Pennsylvania improve their competitive performance. Our speaker, Dr. Enes Hosgor, is CEO and founder at EEme, LLC. He has a Ph.D. in Engineering Public Policy from Carnegie Mellon and a master's degree in Energy and Earth Resources from the University of Texas at Austin, and was also a Fulbright Scholar there. He has also worked in the venture capital area for Foundation Capital and New Venture Partners, and as an energy consulting for IHS Cambridge Energy Research Associates. In addition, he has additional work experience in the oil and gas industry at Schlumberger and CGG Veritas. And with that, I'll turn it over to Dr. Hosgor.
Thank you, Debbie. As you mentioned, my name is Enes Hosgor, the founder and CEO of EEme, LLC, which is a Carnegie Mellon spinout, and we crunch different types of data to map out energy efficiency opportunities. And the problem that we are after is the compliance industry called demand-side management, where electric utilities face state mandates to meet energy efficiency targets. And these programs have been around for more than 3 decades. And today, collectively, electric utilities spend about $9 billion per year. And our solution to that industry is scalable analytics. We crunch different types of data to quantify the sweet spots across residential users and efficiency types. So we are an analytics as a service company that converts different types of data into actionable intelligence for residential retrofit targeting for the different stakeholders. And as I mentioned, we are a Carnegie Mellon University spinout. We're privately owned and backed by Pittsburgh-based technology funds. And one highlight I'd like to share is the successful third-party validation study we have conducted with Pecan project located in Austin, Texas. We are Carnegie Mellon PhDs with core expertise ranging from machine learning to building science to cybersecurity. Before diving, though, into the guts of our business and the technology that I'd like to discuss today, I'd like to paint a broader picture. Before starting EEme and before I started my PhD at Carnegie Mellon years ago, I used to work in oil and gas industry as a reservoir engineer. And whenever an oil and gas developer wants to drill a well, they have limited data, they have limited budget, and all they can do is connect the dots using the different types of data and make educated guesses as to where they should drill their wells. And even then, the likelihood of success is not more than 30%. And different deliberate structured efforts for mapping out the economic potential for different energy resources are relevant for solar, coal, wind, geothermal. And here's a residential neighborhood. You can think of energy efficiency as a reservoir itself, where the potential, the economic potential, varies from one home to another and from one efficiency type to another. And historically, electric utilities have relied on physical home energy audits that are not scalable for cost reasons and workforce reasons. So they only get to cover smaller than 1% of a given service territory, given this approach is not very scalable. And because utilities do not know the efficiency potential of their customers and how likely they are to adopt a given efficiency measure, they are limited to mass marketing techniques where everybody gets the same message. Because simply they don't have this heat map. And that's exactly what we like to change for this industry. And basically quantify where the sweet spots are by customer and by efficiency types, such that the energy efficiency stakeholders can target these locations. And so today's topic is around smart meter data, and smart meters constitute a very hot topic today, simply because about 50% of U.S. homes have a smart meter installed today, which every meter collects highly granular data that opens a new realm of different analytics opportunities and use cases. And only a few years ago, this penetration was about 20%. So we have an unprecedented infrastructure that collects and pushes data on a daily basis. And most utilities and different smart grids, value chain stakeholders do not know what these use cases are and what kind of value these meters can create. And again, there is a variety of use cases one can basically build on using smart meter data that collect granular, frequent whole home usage information in 50-minute or hourly intervals, as opposed to the monthly usage collection that has been the traditional way for utilities to collect consumption data. And such use cases include energy efficiency, demand response, outage planning, generation planning, load forecasting, grid stability, etc. However, at EEme, we are focusing on two primary use cases today, and that are quantifying energy efficiency and demand response. And we have built a solution, a platform that connects the different energy efficiency stakeholders. That include the program administrators, the home improvement energy contractors, the home improvement product retailers, and the residential users themselves. And the way we go about our technology is that we collect and crunch existing data, and we turn that into actionable insights. And such data include utility data from smart meters, public available data like property tax records and voter records, and proprietary building data sets. And we crunch this melange of different data sets using our proprietary algorithms and turn them into actionable business demand side management intelligence. And then in turn, we share these insights at an appliance level. And such appliances include heating, cooling, washer, dryer, dishwasher, water heater, fridge, pool pump, solar PV at the home has one, electric vehicle, and oven, as well as end uses that are typically always on, like baseload and background power. And once we quantify this appliance level insight, that is both about understanding how much they're using and how much the savings potential is, and we communicate such insights to our different portals, one designed for the consumer, where our platform would provide personalized recommendations to individual users without requiring them to provide any user input. And the other solution we have built is for the program administrator, the implementer, where the implementer can slice and dice through their customer base with respect to these predictive metrics of interest we have built. And so these two solutions can be applied to different use cases, which I'll be happy to discuss in a Q&A session. Thank you for your attention.
Great, thank you very much. So we're hoping that some of our listeners will also send in questions. I'll start out with a few that we have on our own. So first, why don't you tell me a little bit more about some of the terms that you use? For example, why don't you talk about, say, what smart meters are and what Pecan Street is?
Sure, absolutely. So smart meters are interesting today because they did not exist in abundance, at least in the US, till about a few years ago. And today, the smart meter adoption across residential users in the US is about 50%. And that number was about 20% a few years ago. And over the past few years, the federal government made a lot of capital investments that was mostly to subsidize the utility smart meter infrastructure. And that was mostly thanks to the American Redevelopment and Recovery Act. But the smart meters, in essence, are relatively inexpensive sensors that collect granular whole home aggregate energy usage information in frequent intervals. To put that into context, utilities typically collect consumer usage information on a monthly basis. But with the advent of smart meters, now they can have that information and other information as well via smart meters every 15 minutes. And that opens up a new realm of opportunities from a different analytics perspectives. And while utilities are already deploying these sensors across their customer bases, not all of them are actively using such data sources. But mostly they collect such data every 15 minutes, and they're basically storing that data on a daily basis as well. And that has different use cases that we can discuss more about later.
Okay. So another one question we have is, oops, 1 second. How do you get your data down to the appliance level that becomes actionable to the consumer?
Sure. So what we do is that we look at historical smart meter usage. And every appliance in a given home has a signature on that aggregate power curve. And we do a lot of signal processing on that smart meter data. And in the academic context, we call this problem, theoretical problem, as source separation problem. And the analogy is that you listening to an orchestra and trying to quantify what the violin is playing in quantitative terms. And so we do exactly that. But just by listening to the aggregated power usage collected every 15 minutes, we can infer statistically as to how much each appliance is consuming. And that does not require any user input, any new hardware, just existing smart meter data.
And you talked a little bit about Pecan Street. Can you tell us a bit more about that?
Sure. Pecan Street is a nonprofit R&D organization located in Austin, Texas, and it also happens to be one of the largest and deepest smart grid testbeds in the world. They have installed sensors across many appliances, covering about 1,000 homes in Texas and outside. So with the advent of smart grid and smart meters, a lot of technologies emerged. What we have built is called lotus aggregation, and has been studied in the academic cohorts for more than a couple of decades. But now that we have the sensors, the smart meters, and the computation resources at hand, now these technologies can have real-world and scalable applications. So what these different technology vendors do is that go to testbeds and validate how their technology works, because at the end of the day, we're not directly measuring any appliance usage. We infer that from the signal that we get from the whole home. And for that, validation, third-party validation is a critical approach you have to take in order for you to basically quantify and confirm that you are creating the value that you're saying that you're creating for the different use cases.
Okay. And can you tell me where your technology is in the innovation cycle? Is it available for licensing, any application?
Sure. We are fully available for all sorts of commercial deployment and licensing activities. We've been conducting research and development on this type of activity, directly speaking, on the smart meter analytics for over 3 years now. And we have conducted several pilot deployments with different utility companies. And having validated technology, and also most recently with the Pecan Street project, we have demonstrated that we have a solution that works and that can scale. And thus, in tandem, we also built infrastructure that will allow scalable adoption.
Do you have to sample the Do you have to sample the smart meter data often, or is this a one-time event?
Sure. Yes and no. So that depends on the use case. What exactly are you trying to accomplish by crunching the smart meter data? And if it's about a one-time virtual home energy audit to assess what's going on in that home, and basically, to complement a physical home energy audit effort, perhaps, or maybe a screening exercise conducted by the demand side management program administrator, that could be a one-time thing. You would just crunch the historical data and then say, okay, here are the 5 top opportunities. Here's the ROI for each intervention, and then you can basically follow on that. But if you're talking about continuous consumer engagement, then you may want to, you may want to crunch frequent streams of smart meter data, say on a daily or weekly or monthly basis. So while we have the capability for crunching all types of data and all types of frequencies, it very much depends on the use case and what you're exactly trying to solve.
And are utilities generally agreeable to sharing their consumption data?
That's yes and no. So utility usage information is a highly private piece of information that is just generally not accessible to the general public. And however, utilities typically outsource their work to third parties, consulting firms like ClearResult or ICF or other companies who administer the program design, implementation, and evaluation. So it is not uncommon for third parties who is in charge running the programs on the utilities' behalf. So in those instances, it is basically common to access and crunch such data, but you will be subject to certain NDA rules.
And how are you different from your competitors?
Sure, there's a number of ways we are different, but to put things into context, this industry, demand side management industry, $9 billion industry, has historically been run by consultants who are by nature analysts and who use spreadsheets. That is still pretty much this industry norm to date, and it's been the case the past few decades. There has been a handful of technology-oriented companies that emerged over the past 5+ years that like to change some of these elements to the consulting-driven demand side management industry. So while we like to compare ourselves to the status quo and the consultants and analysts, I can also compare ourselves to the different technology vendors that have emerged recently. For one, if you're talking about smart meter sensor analytics, in that space, most vendors you will see in this space is that they will mostly require for you to install new hardware. In other words, smart meter data is often not granular enough for these vendors, and as such, they would like to install their home area networks gateways that can cost a couple hundred dollars per piece, and for them to get more granular data at a second level, and such that they can do intelligent analytics. We don't require such data. We welcome that data, but we think with existing smart meter data, we can still accomplish a lot of things. But perhaps most importantly, when you look at this space, again, there's a handful of vendors who do appliance level disaggregation, but to our knowledge, nobody has come forward with a publicly shared third-party validation study. But perhaps more importantly, none of them have conducted extensive validation studies. There's been only a couple of studies in this realm, basically conducted for third-party commercial vendors, and they were subject to two limitations: either mock homes that were like 10, 15 in number, in order of magnitude, or they were subject to 1-2 month long validation periods. Whereas we have conducted the largest of its kind study covering 270 homes and 12 months. And to our knowledge, no vendor is in a position to make the claim that they have extensive validation studies in the form that we have.
Okay. Second. What are I'm having somebody write down the question because it's not popping up all the way. Let me switch to another question. I'll get to one from our guest here. What do you think is the primary benefit of this technology?
Sure, there's a nice array of applications of this technology. So knowing what's going on in a home for a given time period in different end users appliances has a variety of applications. And that can include energy efficiency, demand response, outage planning, generation planning, different types of load forecasting, as far as how grid stability can be affected by, and how transmission and distribution operations can be improved further. So smart meter data, again, is very rich in content and is subject to a variety of different use cases. However, at EEme, we are focusing on two primary use cases today, and there are energy efficiency and demand response. So basically, what we do is that we quantify the energy efficiency and peak demand reduction potential for each individual home, for each end-use appliance type. And that has consumer-facing applications and utility-facing applications, and such that they can meet their energy efficiency and demand response targets at a granular level. Because today, no organization has a household and appliance level understanding for their service territories. Everything is at a substation level. But with appliance level disaggregation, now you can actually control and understand, manage your customers in more grid-friendly ways.
And what are the most likely energy uses that you can show to the consumer in terms of specific appliances?
Sure. So that depends on the type of interval data we get. But if we're talking about the typical smart meter frequency realm that is on the order of 15 minutes, sometimes lower, sometimes higher, we can break that down to approximately 10 plus end uses. That include heating, cooling, washer, dryer, dishwasher, fridge, water heater, pool pump, and if the home has one, a solar rooftop panel, electric vehicles, as well as oven. And of course, we also quantify the base load and background power sources that are typically always on.
And have you provided analysis for commercial industrial facilities? Are there different challenges in that segment?
Mm-hmm. Sure. Actually, while we are focusing on the residential context primarily, we're also dipping our toes in the commercial industrial context, where our algorithms are also transferable. To that end, we are currently working with the Department of Defense alongside with Carnegie Mellon School of Architecture, Siemens, and OSIsoft, where EEme, our company, is providing the smart meter analytics for a military base, which is mostly consisting of commercial industrial buildings. And so our analytics certainly has applications in that area, but mostly in the commercial industrial context, you will see these end uses being sub-metered. So the necessity of load disaggregation is not as critical as in the residential context, where you won't see as much sub-metering.
And do you have any patents on your analytics?
We are all protected by trade secrets at this point, and we have patent applications that are pending.
Okay. What kinds of companies do you work with now, and how do you work with them?
Sure. There are three types of companies that we work with and target working with at this point. And the primary category, as one can imagine, is that the electric utilities in the United States who face an energy efficiency state mandate. And so we basically help them quantify and spin through millions of customers as to who deserves what kind of energy efficiency intervention time. Sometimes for a customer, it's a new water heater, and for another customer, it might be a smart thermostat. And yet for another customer, it might be a window replacement. So we help them identify, diagnose all of their customers without installing new hardware or without physically inspecting any buildings or without requiring any user input. So our analytics is highly scalable. And once we have access to smart meter data, we can do this analytics for everybody in a given service territory. But the other types of customers, organizations that we target working with are twofold. One being the technology providers who sell software and hardware to utilities. It can be smart meter software and hardware. It could be meter data management software. It could be billing software. It could be customer engagement software, where we envision ourselves being a new layer of analytics on their offerings. And finally, we also target third-party program administrators, the consulting firms that I briefly referred to earlier in my presentation, basically who are in charge of administering, designing, implementing, and evaluating the utility-run energy efficiency programs. We also target those firms as customers and partners.
And is this possible for gas utilities, and would there be value in that?
Sure. Gas utilities, that's certainly a question of interest, but the mandates around natural gas usage are not as strict compared to their electricity regulatory counterparts. So for that reason, natural gas utilities may not see this as viable approach. However, we certainly have the capability of crunching natural gas monthly usage and smart meter interval data which is not as available as electricity meters, but we certainly have use cases in natural gas as well as water.
Okay. And what do you think are the primary challenges or hurdles for this technology?
The technology, this type of technology requires a lot of validation. And our community, the low disaggregation technology community, both academics and vendors, we have not gone through a lot of validation to understand what the use cases are, what the benchmarks, reference points are for different types of accuracy values that we can achieve with different types of smart meter data and for different types of appliances. So the main challenge is that validating that this type of analytics that is not based on actual measurement, but inference and prediction. So we have to validate the technology as a analytics vendor community. We have to validate our technologies and work with test beds and utilities to quantify and confirm that this technology actually works before actually full scale deployment. And we believe that we are past that point now that we have completed our largest of its kind study with Pecan Street project. But the other challenge that we all face in this industry is that it is a very slow moving industry, and you have to find the right partners, the right utilities that are progressive to try new technologies. And that is certainly one of the challenges that we have faced historically.
What kind of business and manufacturers might be interested in using this technology? In other words, are you going beyond residential to industrial companies and other organizations that also are interested in improving their energy efficiency?
Sure. That's not our core focus at this point. Our core focus is on the residential users. However, as I said, our algorithms are transferable to the commercial building, industrial building context, and which we're today testing with the Department of Defense. But again, that'll be more of a long-term endeavor than the residential space.
And are you working with other agencies beyond the Department of Defense?
No, we don't work with any other government agencies, but we do work with other economic development agencies as funding partners.
And can you talk about how much this technology costs and what's your economic model?
Sure. Without going into too much detail, we have a subscription model that is based on a per household per year fee, and of course, depending on the use cases, what kind of applications we would want to deploy, whether it's a consumer-facing solution or a utility-facing solution, we would need to prepare a different quote for that, which I can discuss with interested parties after this webinar.
So I'd like to thank everybody for our questions thus far. This is your last chance to get in questions. Before we move on, I have just one last question on our part. How did you become interested in working with this technology?
Sure. So before I got my PhD at Carnegie Mellon, over 6 years ago, 7 years ago, I was in oil and gas consulting. So I was a reservoir engineer helping oil and gas companies map out their resource potential. And there are many similar principles across these different energy resources, as I mentioned during the first part of my presentation. So I was mapping out the oil and gas potential in a reservoir using data and statistics. And then when I started my PhD at Carnegie Mellon, I initially worked on geothermal and resource mapping in that area. So I saw that there are many common themes amongst all these energy resources. And we can also think of energy efficiency and reservoir. So I got really excited by the opportunity that I can transfer my background in oil and gas and geothermal into the energy efficiency context, which operates differently, but still, very similar principles apply.
Okay, well, great. Thank you very much. This is a very interesting presentation.
My pleasure.
I'd like to remind people that if you want to find more information about the Institute for Energy Innovation and other energy technologies that have been developed at Carnegie Mellon, go to our website at cmu.edu/energy. Thank you very much for coming to our webinar and for your great questions. For more information on the Institute for Energy Innovation, visit our website at cmu.edu/energy. And for more information about Catalyst Connection, visit catalystconnection.org. Please join us for our next webinar, which is on robotic airboat water quality monitoring from a company called Platypus, another CMU spin-out, on Friday, April 17th, 2015 from 12 to 1 p.m. You can register by going to tinyurl.com/robotic-airboat. If you'd like to know about future webinars and other activities at the Institute for Energy Innovation, sign up for our newsletter at tinyurl.com/ScottNews. A video of this event will be posted on YouTube and the Scott Institute webpage. Thank you again for participating.